All right, we're going to go over a problem from Cracking the Coding Interview, the 6th edition. So it's problem 4.9 BST sequences. So the problem is given a binary tree with distinct elements, print all the possible arrays that could have led to the tree. So for example, let's just say that we have this tree here, 9, 3, 15, and 1, 5, 20. Okay, so say we were creating this tree from scratch, right, from some array of numbers. Well, the first node that had to have been in this array was this 9 here, because we would have, at the very beginning, we would have started with no tree at all, right? And we would have had to have inserted this 9, and that would have been our root. And then whatever numbers come next, those would be the children, right? And then the grandchildren and all that. So let's put that back. So we agree that the 9 had to have come first. And now it doesn't actually matter what order the children come in. So we could be 3 and 15, or it could have been a 15 and a 3. It really doesn't matter because let's just say that we had a 3 first. Well, the 3 would just go to the left. And then the 15 would go to the right. Or yeah, it would go to the right. All right. And if we had a 15 first, well then the 15 would still go to the right and 3 would come next. And it would just go to the left. Cool. So and then when we do the children, let's say we go to the 1 and 5 next. So the 1 and 5 can come in any order. They just have to appear in this array after this 3. So for example, we could have 1, 5. We could have had 5, 1. But the 3 had to have come first. So the key property I'm trying to get you to see is that the only thing that matters in the ordering is that we keep the roots of all the subtrees before their children. So in our output arrays or in the okay. So and then the order of the children doesn't matter, right? So as long as the root of each subtree has to come first, then the order of the children doesn't matter. And as long as we preserve that, we're good. So now let's think about how we're going to do this. So we want to return all the sequences that could have or all the array sequences that could have led to this. So what we're going to do is we're going to recurse down to the bottom. And what we're going to do is we're going to get all the sequences from the left subtree and all the sequences from the right subtree. And then we're going to combine them and prepend the 3. So for example, let's say we were just doing this subtree here, the 1, the 5, and the 3. So where 3 is the root of the subtree. So 1 would be the left subtree sequence. This would be all the sequences in the left subtree, which would just be 1. And we would just have a 5 here for the right subtree, right? What are all the different ways that we can combine these? Well, this could be 1, 5. This could be 5, 1. And what we're going to do is we're going to prepend the root to the front of both of these so that we end up with 3, 1, 5 and 3, 5, 1. And the reason we prepend is because, again, the root had to have come before the children. Okay. And we're going to recursively do this. So like when we get to the 9, we're going to take we're going to take all the combinations from this subtree and all the combinations from this subtree, all the combinations from this subtree, and we're essentially going to combine all the combinations from the left and right subtrees, and then just prepend the 9 to all of those combinations. So you're going to see how since we had to prepend the 3, we're going to prepend the 9. So that's essentially the whole algorithm. And okay, so one thing to notice, one thing that's kind of important to note is I could go with this example. I'm thinking of how I want to do this. Actually, yeah, let's just do this one. So these two combinations here, right? 315 and 351, these are all the combinations of this subtree here, where 3 is the root of the subtree. Well, if I want to combine this with, say, all the combinations of this subtree, which this would just be 15 and 20. There's no other combination here because this 15 must come before the 20 since it's the root of this subtree. Okay. So if I wanted to combine, say, all the combinations from this subtree and all the combinations from this subtree, or all the sequences, whatever you want to say, so that would just be these here, these would be the left, and this would be the right. Well, what I'm going to do to combine these, let's say I start with this. What I'm going to do is I'm going to maintain the relative ordering in each array. So this 3 has to come before the 1, and which has to come before the 5. And the 15 has to come before the 20. But what I'm going to do is I'm going to interleave these in all the possible ways. And I'm going to explain why the relative ordering matters. But like, for example, when I say interleaving, we could, while maintaining the relative ordering, we could have 3, 15, 1, 20, and 5. So notice I still maintain the relative positioning. So 3 came before the 1, which came before the 5 in this left sequence. And in the right sequence, we had 15 before 20. We do have the 15 before the 20. And another possible, I'm just going to do one more just because why not? We could have done, say, 15, 3, 1, 5, and then 20. That would work too. So like, notice the 3 came before the 1, before the 5, and the 15 appeared before the 20. But what I'm doing here is I'm just interleaving them in all the possible ways while maintaining the relative positioning within each of the individual left and right arrays. Okay, so why does the relative positioning matter? Well, we don't want to just do randomly like mix and match the numbers, because notice like if I want to find all the possible like combinations of interleaving them, uh, I still have to do this array down here. If I want to do all the like I need to mix and match like this. So this array has to get interleaved with this array, but this array also has to get interleaved with this array. So you don't want to just mess up. We don't want to, one, we need to preserve the root, right? Like this 3 had to appear before the 1 and 5. So the ordering of these arrays actually matters. So like this, if this 3 showed up before this 5, 1, well, that's important. We need to maintain that because we don't want this 3 to appear after the 1 and 5 because that's just not possible to create that. Like if we had 1, 5, 3, well, then it would be impossible to create this subtree from that array. Okay, so basically my point is that the relative positioning matters, and if we don't maintain the relative positioning, we could end up messing up roots of the subtrees, but we could also end up with duplicates. Because let's say I just mix and match this 1 and 5, right? Like if I did this, basically this 1 and 5 could end up duplicating with this 5, 1 if we didn't maintain the relative positioning. I don't want to get too into it, but I feel like you can see that. Like if I just randomly decided to put the 5 before the 1, well, that would just end up with me duplicating this array here. So that's why we need to maintain the relative positioning when we're combining them. Okay, let's actually get into the code. I think that's enough explanation. I'm going to leave the tree here just in case I need this for demonstration purposes later, and let's just get right into it. So, you know what, let me paste this out at the top so we don't get distracted by it. All right, so now let's start with the code. So what are we going to do first? We're going to create the thing and we're going to return. I always like to do that just to get the ball rolling. Cool. And you know, I'm going to call this all sequences because that's essentially what this is. It's all sequences that we're going to return. Return all sequences. Okay. And let's start with a base case. So if the node is null, then that's an issue, right? I would say that's our base case. That's a good base case. If the node is null, then what I'm going to do is I'm just going to add an empty list. And I'll explain why in a second. Let me just type it. So we're going to add an empty list, and then we're just going to return all sequences. Cool. So the reason I'm adding an empty list, it just makes the logic easier. And for example, up here, why is this spacing wrong? Let's just you know what? Let me copy and paste this example really quickly. And let me explain why adding an empty list just makes the code simpler. So see this 15 here? It has a right subtree, right, of 20, but notice it has no left child here. This would be, say, null. Null. Let me put a little backslash in there, or a forward slash. Okay. So when we're combining all the sequences from the right subtree and all the sequences from the left subtree, it just makes our logic a little easier when we can just say, okay, just combine all the right sequences with an empty list, which would just be this empty list here, instead of us having to check for null later on. Because I mean, we could just not add this, right? I could just, delete this line, and then we just check for null later to make sure that we're actually combining with something. But yeah, so that's just essentially why I'm just taking care of that case here, where we're adding with a null list or a null subtree, whatever, a null left or right subtree. Okay. So now we need to get all the sequences from the left subtree and all the sequences from the right subtree, then combine them. So let me declare some variables here. So let's get all the sequences from the left equals node, or no, sorry, all sequences. So we're going to recurse, get all the sequences from the left subtree, and we're going to do the same thing from the right. And just change it to node.right. And I'll call this right sequences. Cool. And so now we have all our sequences from the left, all sequences from the right, and now we just need to combine them. And we need to prepend the root. So this node needs to be at the front of all the combinations of these left and right sequences, right? Because we prepend the root to the children. So let me create another linked list. And I'll explain you'll see why I'm making a linked list and not just like hard coding the node into the front. But yeah, you'll see. So new linked list front, and we're just going to do front.add node.data. So data is just, I'll show you guys what so here's the tree node class. The data is just an integer, okay? And we have a left and a right and some parent. I didn't write this tree node class. This is from the CTCI GitHub, and I'll probably link it. But anyway, let's just keep going. So we have the front linked list. This is just whatever's going to be at the front of these two sequences, left and right sequences. So in the beginning, it's just going to be this one little node, this node's data, because the root needs to go before the children, okay? And now we can just combine these left and right sequences and then add it to our all sequences. So let's loop through all of it. So I is less than left sequences dot size plus I, and then we're going to loop through our right sequences. We're just going through all the possible ways that we can like essentially like cross multiply these left and right sequences. And we want to say all sequences dot add all, and we're going to weave the left sequences with the right sequences, append this front to the combination of these two. And so we're going to weave it together. And we could say weave, interleave, whatever word, or combine, like whatever word you want is fine. And let's see, is that right? So yeah, we weave these together, and then we just add all the combinations into our all sequences, and then we're going to return all sequences. Yeah, so I think that this part of the code is actually done. I think this method is complete. So now we're going to move on to this weave method where we actually handle like, weaving these two together. So let's write that really quickly. So private static, and it has to be static because this is just the static main is calling on a static method up here with the all sequences, and then yeah, anyway, it has to be static. So private static, what are we returning here? We're returning all the combinations of combining the two sequences. We'll just copy paste this, and I'm just gonna say weave, pass in a linked list. So the front, all the nodes that we put in the front. And I know this is I'm going to explain this front variable later, but I know it's a little confusing because I only added one node, but you'll see what we're going to do with it later. Front, this would be the left sequence. Why do we not have room here? Is there a way to make this smaller? Oh, that might be too small though. No, let's just keep it like that. Shoot. I want to fix the spacing on this. You know what? I'm just going to mess with the indentation a little bit. We're just going to bring this over here just so we can have some nice methods. Okay. And then we're going to do the right sequences. Okay. I know this indentation's off, guys, but it's because it looked gross if I didn't do that. So anyway, so what are we passing in here? The front, the left sequences, and the right sequences. Okay, and we're going to do first, we're going to write the body of the code. I would explain the base case first, but the base case is hard to explain without actually seeing the meat of the actual body of the code first. So let's do the real, the meat of the code first. So what we're going to do in this method, just out loud, I'm going to say it. So we're going to take one element from the front of the left sequence and append it to front. And then we're going to recurse and weave our new left sequence with our new right sequence. And then we're going to do the exact same thing with the right. So we're going to take one thing out of the right sequence, append it to front, and then we're going to recurse on our new, with our original left sequence and our new right sequence, which just has one less element in it. So we're just going to keep recursing by taking one element either the left or the right. And we're just going to add all of those combinations to our sequences and return that. And basically when we hit the bottom of the recursion, so eventually one of these will be empty, right? So because if we're constantly we're either taking something out of here or something out of here, and we're just alternating, like taking something out. And eventually if we take enough things out, one of these will be left empty. And when one of these is empty, we're just going to add the rest of them to the front. And then front, what we're going to do is we're going to make a copy of it and return it. And front will essentially, but at the bottom of our recursion, front will end up holding it'll hold one sequence that could have led to the array, or it'll lead to one sequence that is a combination of this left and right sequence. Okay. And I know it's a little rough saying it out loud, but like in following along, but I think as I code it, I'm just exposing you to it, and then when I code it, it'll probably make a little more sense. So let me start by okay, so first we're going to so we're going to take something out of our left sequence, right? So we're going to say remove first. We're just going to remove the first thing out of the left sequence. And what we're going to do is we're going to add it to the front array. So add is just going to add this element to the back or the end of the front array. So yeah, so this is just appending here. Okay. And now we're going to what are we doing here? We want to say all sequences. Oh, sorry, I didn't actually create. Let's actually create the thing that we're going to return before we write anything else. So this is like all combinations or all sequences equals new. We'll just say linked list. Boom. Okay. So what we're going to do is this all sequences is what we're going to return, right? So let's just return that. And we're going to, once we remove something from the left sequence, we're going to remove the thing at the front of the left sequence and then just add it to the front. We're going to say all sequences dot add all weave. And I'll explain this, I promise. Oh wait, I can't do that on this line, sorry. We need to do weave, pass in front, pass in left sequence, pass in right sequence. All right, sorry, that was a little rough. Let me just say that out loud one more time. So we're just taking the first thing out of the left sequence, adding it to the front. And then we're going to pass in front into weave. So we're going to recurse, pass in front, which is our new front. We're going to pass in our new left sequence, which just has one less thing in it, and then pass in the original right sequence. And what we want to do is we want to add all the combinations that we get from this, from weaving. What are all the combinations of weaving this together into our all sequences? So we want to add that. So add all, weave, and boom. Okay. So now we need to do the same thing for the right side. But before we can do the same thing for the right, we need to undo this change that we did here, where we removed something from the left sequence and then added to the front. We want to undo it because we don't want to mess up that list for any other recursive calls. So we want to remove last. So this added it to the end, right? So we're going to remove the last thing that we added there, and then we're going to add it back in. So left sequence dot add at index 0 the thing that we added to the front. So we're just undoing this change that we did there, so that we don't mess it up for our next recursive call. So, and then what we can do is just do all sequences, add all. Oh, sorry, I'm getting ahead of myself. So now we need to do the same thing that we did here for the right side, where we remove something. So we remove something from the left and add it to the front. Well, now we need to remove something from the right and then add it to the front. So let's do that here. So front dot add right sequence dot remove first, and then we can get all the combinations of weaving them together. Pass in front, pass in left sequence, pass in right sequence. Okay. And then we need to undo our change one more time because we need to undo this guy right here where we removed from the front or removed from the right sequence and then added it to the front. We need to undo it because we don't want to mess up other recursive calls. So let's do right sequence. Oh my God, I can't type. Right sequence dot add 0 front dot remove last. Cool. So we undid that change. And now all we have left, so this, we're missing a base case and I'm going to get to it right now. But you can see how like eventually we're just removing something from the front of the left sequence, adding it to the front, and then we're going to weave our new left and right sequence together. And eventually either the left or the right sequence will be empty. So we need to handle this base case. If the left sequence is empty or the right sequence dot is empty, and this actually is, I'm just moving all sequences variable to the top because we're going to use this. So if the left sequence is empty or the right sequence is empty, then that means that we can just append the remainder of basically one of these might still have elements, so we need to add the remaining elements into the front array. So first I'm going to create a copy of the front. So link list of integers, and we'll just create copy equals front dot clone. Or we could call this clone. Let's just call it clone because it's clone here. Okay, so we're going to clone the front because this is essentially holding a combination of the sequences. And now I'm going to add everything from the left sequence in case it's not empty. Add everything. Oh, this should be add all. And we're going to add everything from the right sequence in case that is not empty. Because one of these might not be empty, right? They could both be empty, but one of them could not be. So we're just going to add the remainder, whatever's remaining left, into our clone of the front. And then we can add this into our all sequences. So this would be clone.addAll. Oh no, sorry, we just do clone. Wait, what am I doing here? This would be clone.add clone. Yeah, and then we could just return all sequences. Okay. So basically, once we hit the bottom of our recursion, we just check if one of these is empty. If one of them is empty, then we create a clone of our front. And the reason I'm creating a clone here is because we don't want to mess this up. Because front is being passed into a lot of recursive calls, right? So we don't want to mess up front for any other recursive calls. So that's why we're creating a clone here, because we're about to add more stuff into this front array. And then, okay, so then we just add this copy of the front or the clone of the front to our all sequences, and we just return it. Okay, so I think this is done. Let me just run it. What did I do wrong? Oh, okay, this front.clone, I actually need to cast this. Okay, I think clone here is returning an object. So I think that's it. Let's try running that one more time. Line 31. Let's see what's wrong with this. Oh, I'm passing in the, I'm dumb. I didn't do left sequence.get I because we would just want to get one sequence out of all these left sequences. We don't want to do right sequence.get j. Okay, my bad. I missed actually passing in the indexes, but now let's run it. And line 58, what's wrong with this? All sequences dot, this needs to be add all. So that so it needs to be add all, not add. All right, let's run this. So I'm just going to run this with my example. So 9, 3, 15, 1, 5, 20, which was this tree up here. Just run it. And yeah, so our 9 appears first. Then 3 and 15 were the children here. So 3 appeared next, and then the 15. So, and then 15 could also appear before the 3, right? So that's why we have 15, 3 here. And yeah, I mean, just like eyeballing this, it looks right to me. But yeah, if I see any, if like if there is a problem with this code, then I won't upload this video. But I'll double check it right after I stop recording. Um, but yeah, this is how you're supposed to do this problem, or at least this is how like the CTCI book goes about it. And I think it's relatively intuitive. It's just a lot of I don't know, kind of like wrapping your head around like how the different parts are working and like why they work that way. But yeah, so if this helped, you can give it a thumbs up. You can subscribe. All right, bye.